Hello, my name is Amari Smith, and I'll be talking about my energy comparison of fuels lab. So the first step in this lab, obviously, like all labs, you want to have your safety equipment on, so gloves and goggles. But after that, I used a digital scale, and I was told to tear it so that it displayed 0.00 on the scale. After that, I use a pipette to add 10 milliliters of distilled water, which I purchased from Walmart. I added 10 milliliters of distilled water to the graduated cylinder. Next, I recorded the mass of the water, which I got 9.65 grams after doing my calculations or my measurements. Then I calculate the density of the water by using the density equals mass of water over volume of water equation. I got 0.965 grams per milliliter for the density of the distilled water. After that, I measured the temperature of the water by using a thermometer, and I got 24.7 degrees Celsius. On the second part of this lab, I turned the scale on and tiered it once again to show 0.00. After removing the cap, I placed the canister on the scale to measure the mass, which was 50.48 grams. Next, I used a funnel to pour the isopropyl alcohol into the canister. And then I measured 5.0 milliliters of alcohol and added it to the canister. After that, I had to reassemble the canister by placing the wick inside of the opening. And this process was a bit of a pain in the butt for me because the wick, it wasn't a smooth process to put it inside of the cap. Next, I placed the canister with the alcohol in it on a scale and measured it by subtracting the mass of the canister with alcohol from the mass of the empty canister. I got 26.11 grams after that. Next, it got a little interesting and a bit annoying. So the next steps involved me using the glass beaker of distilled water, placing it on top of the burner stems, and positioning the canister with alcohol in it in front of the stand. After that, I recorded the initial temperature of the water, which was 24.7. Then I used a lighter to ignite the wick of the fuel canister, but unfortunately, the wick would not stay lit for too long. I attempted it multiple times, but it just would not stay. The fire would not stay. So I just recorded the temperature as it was after the attempts that I made, and the temperature was 38 degrees Celsius. It's the third part of the lab. This part required many of the same actions, just substituting the candle wick. The candle was much more easier to ignite. Some of the numbers. So the initial mass was 10.17 grams, and the final mass was 9.89 grams. The initial temperature was 24 degrees Celsius. Final temperature was 37 degrees Celsius. And kind of going back and forth between the numbers from both the from both the candle as well as the canister. The change in temperature for the fuel canister was -14, while the change in temperature for the tea candle was -13. The number of calories absorbed by water for the fuel canister was -331.918952 calories. For a tea candle, it was -128.501538 calories. For grams of fuel consumed for fuel canister, it was -0.59 grams, while for a tea candle, it was -0.29 grams. And lastly, the calories per gram for the fuel canister was 562.57 calories per gram, and for the tea candle it was 443.11 calories per gram. So the last part of the lab was the questions. The first question was which was more efficient, which fuel was more efficient, and I said the fuel canister was the most efficient because it produced 562.57 calories per gram, burning off the isopropanol at a high rate. The second question was explain the differences in the efficiencies of the fuel you tested based on the chemical structures of the fuels. And I said the fuel canister was a more efficient fuel source because it produced more calories per gram, 562.57 calories per gram, compared to the tea candle, which produced 443.11 calories per gram. The third question was diethylene glycol is an organic compound used as a fuel in heating cans. Based on its structure and your data recorded in data table 3, how do you hypothesize its energy efficiency compared to its isopropanol and paraffin wax? And I said my hypothesis is that due to the number of oxygen atoms, diethylene glycol will have that higher energy efficiency of -900 calories per gram. The last question was, what are the possible sources of error in this experiment, and how could the errors be reduced in future experiments? I said possible errors could include miscalculations, improper measurements, and improper assembly of the canister. These errors could be reduced by rechecking measurements before adding them into the designated instrument, rechecking all calculations, potentially even doing them twice, and proper research on how to assemble a canister could also be helpful as well. And that was the last part of the lab. This lab in particular was particularly challenging for me because it didn't go as smoothly as I would have liked it to. Ran into a few errors, and it made this process a bit frustrating, but at the end of the day, it was still cool to kind of see the effects of everything, just see the calculations and things like that. And it was just a great experience overall. Thank you.